Today you will be constructing and interpreting box plots and comparing the two. If you notice at the bottom of the screen there is this link. It's just a video to kind of see where box plots can be applied in real life. So I encourage you to check it out. Box plots display quantitative data using the 5-number summary. So when we say it uses the 5-number summary, the start of the whisker, that is your min. The start of the box is your first quartile. The line through the box is your median. The end of the box is your upper quartile or your third quartile. And the last whisker, that is your max. So that's your 5-number summary. We especially like it when we are comparing groups. So for example, this is what you have probably seen from Algebra 1 classes. Okay. Well, now we will add multiple box plots so that we can compare. So sometimes we will see them vertically, and sometimes we will see them horizontally. The first step when we're constructing a box plot, and again, this should be a 0.2 for the minimum. You're going to draw a single axis spanning the range of the data. You're going to title it, and you're going to put on the label. So in our case, we're looking at speeds, so we're going to assume it's in miles per hour. Okay. I typically don't like to do a vertical box plot, and you do you. I typically will draw mine horizontally, but to save space, decided just to keep it vertical. Also, things to note, notice how we have a consistent scale. Our scale is going by 1.5. Your scale, just like with the histogram or a bar chart or any other data value, your units have to be consistent. Our second step is to create a box using the median and the quartiles. So note our lower quartile is at 1.15, so we approximate it, and that's the lower end of our box. The median, we draw a line in the middle. And the third quartile, 2.93, again, we approximate it, and that's the other end of our box. And there it is. Our third step is to find the fences. All the fences are our outlier check. When you do a box plot for me on the upcoming formative and on the summative, I need to see that you've checked for outliers. Okay? They do not appear in the final display, which is why they are dashed. To find your lower fence, okay, this is how this is constructed. So the lower, you take your first quartile, you minus 1.5 times the IQR. Okay, if you have forgotten what IQR is, remember IQR is equal to the third quartile minus the first quartile. To find the upper fence, you take your third quartile and you add 1.5 times your IQR. Okay. So notice for our lower fence, we took our first quartile minus 1.5 times our IQR. If we were to take 2.93 and subtract 1.15 from it, we do get 1.78. As a result, we have negative 1.52. Now, as a visual, again, in your notes, it is dashed. If we were to look at our upper fence, note to self, we took our upper quartile, the 2.93, we added 1.5 times our IQR, same as the lower fence, and we got 5.6, which is approximated here. Again, you do not need to put the fences in your box plot. The biggest mistake I see students make is they think the fences are the tails of their box plot. The next step is to draw our whiskers. We're going to extend to the most extreme data values within the fence, okay? So if the data falls outside the fence, stop at that fence. So if you recall, our lower fence was negative 1.52. Because our smallest data value was positive 0.2, we just graph it like normal. If you recall, our upper fence was 5.6. 5.6, well, 8.67 is higher than 5.6, so we stop our whisker at the fence. Okay, so here's our fence, we stop the whisker. Okay. Our next step is we're going to draw any outliers. Okay, remember these are values 1.5 IQRs above, beyond the box. Far outliers lie more than 3 IQRs from the box. The only time you will see far outlier on the assessment is in the vocabulary. At this point in time, all you need to do is mark the 8.67 as your outlier. Now the reason why these other dots are here, if we had all of the data values and not just a 5-number summary, we would be able to determine how many of those outliers we actually have. But because we don't have all the data and we only have the 5-number summary, we're just going to plot the max. For side-by-side box plots, we use them to compare groups. This is the critical thing. They have to be on the same scale. If they are not on the same scale, that's bad. You can't compare if they're not on the same scale. Okay. So this is our side-by-side box plot. In our next problem, we're going to practice constructing side-by-side box plots. On your practice, note to self, if we're going to use our 5-number summary, okay, we have both 5-number summaries for temperature changes in various coffee mugs from both Scooters and Starbucks. Okay, we need to start off by making sure we do not have any outliers. Okay, in order for us to do that, we need to find the upper and lower fences. So I'll do Scooters in green. Remember the lower fence. We're going to take the first quartile minus 1.5 times the IQR. If I take 4.5 minus 1, that gives me 3.5. When we do our calculations, the lower fence does end up being negative 4.5. The upper fence for Starbucks, this time we're going to take the third quartile, 4.5, plus 1.5 times our interquartile range. And it does end, and it should give us about 9.75. We are going to do the same thing for Starbucks. I'll do it in blue, to make sure we have no outliers. Okay. So the lower fence for Starbucks, our first quartile is 6.5 minus 1.5 times the IQR. Again, we'll take Q3, subtract Q1. 14.25 minus 6.5 is 7.75. And that gives us a total lower fence value of negative 5.125. The upper fence will take our third quartile, 14.25, plus 1.5 times our IQR. Okay. And this should give us an upper fence value of 25.88. Okay. Now, note to self, our min and max, does it fit in between the lower and upper fence? 6 is between negative 5 and 25, so is 17.5. So Starbucks has no outliers. if we go back to the scooters, we need to ask ourselves, does our entire 5-number summary fit in between -4.5 and 9.75? Well, 0 fits in between, and so does 7. So that means scooters also has no outliers. Whenever we construct our box plots, a couple things we need. We need a consistent scale. Notice the minimum for scooters is 0 and the maximum is 17.5. If it were me, I would either go by 1s or I would go by 2s. You can really do whatever you want. You have to make sure you show me labels. If I have no idea what scale you're going by, I don't know how to grade you. Okay. Other things you need a title. So temperature changes in coffee mugs. Okay. And you also need a horizontal label. So I know what our context is. Well, it'll just stay over there. Other things you need to give me a label for both scooters and Starbucks. You have to determine which box plot goes with which data. If you do not do that, I don't know how to grade you. Okay, so because we had no outliers, we determined that on the last slide. We just plot the 5-number summary. So I know the lower whisker for scooters is at 0. Ooh, my bad. Move it back, I think. Okay, so the minimum is at 0. The Q1 is at 1. The median is at 2, and for right now I'm just going to draw a dot. The third quartile is at 4.5, and that's my, and then the max is at 7. Okay, so there's my first box plot. For Starbucks, again, we determined it had no outliers from the previous slide, so we will graph our minimum at 6. We will plot our first quartile, 6.5, our median, 8.5, our upper quartile, 14.25, about there. And our max, 17.5. And there are comparative box plots. Couple things that we notice here. Note that almost all of Starbucks temperature ranges are greater than the scooters. Okay, if I were to draw like a dashed line down to my scale, see how almost the entire blue box plot is greater than the green. Okay, so that's something we can use to compare. Also note to self that the boxes itself, the Starbucks box is much greater than the scooters box. What that means is there's more variation with Starbucks temperature mugs compared to scooters, meaning scooters have a more consistent temperature change in their coffee mugs. Other things we can determine the shape. This distribution for Starbucks looks skewed right, and so does scooters. Okay, and then you can talk about spread. Okay, we can just look at the range. So I know for scooters the spread is 7, and for Starbucks the spread, it looks about 11.5. Okay, so things we can do to compare. This leads into us comparing the box plots. So we talked about shapes, symmetric and skewed, etc. in the coffee example. We didn't talk about medians, but if we were to go back and look at the previous slide, scooters had a lower median than Starbucks, patterns, things like that. We did talk about IQRs and different variations in spread. And we also determined there were no outliers. So we're comparing box plots. Those are the key things we want to look for. You may be asked to compare with two box plots, then one has an outlier. So the example reads, roller coasters are a thrill ride in many amusement parks, and thrill seekers want a coaster that goes fast. There are two main types of coasters, wooden tracks and steel tracks. Do they typically run at different speeds? We want to compare the speeds of the wood and steel roller coasters. If we look at the picture, we note that steel has an outlier for sure. The wooden roller coaster looks like it has a more symmetric shape than the steel coaster. We also note that the wooden coaster has a smaller spread than the steel coaster. Okay, meaning wooden coasters have a more consistent speed. On a test or quiz, you don't need to write me a paragraph like we see here, but this is just a really nice detailed example to kind of get you thinking what direction we're headed. So overall, wooden track coasters are slower than steel track coasters, right? The fastest half of steel coasters are faster than 3/4 of the wooden coasters. Okay, so what that means, the half of the steel coasters is here, right? And if I were to look at the other box plot, that's almost to the third quartile or the upper quartile. And this much is all faster. Okay, so that's how we can say that. We do have similar IQRs. The lengths of the boxes are pretty similar in size, and the range of speeds among steel coasters is greater than that of wooden coasters, which we already discussed. The distribution of wooden coasters is roughly symmetric, and the steel coasters are skewed right with an outlier at 120 miles per hour. This is your assignment for this lesson and your math humor.